So we're going to cover ANOVA here, and let me go on and get things started. Does anybody have any questions really quick before we get out of the gate here? Anybody? No, good. All right, hang on a second. All right, Christy, what are you seeing there?
The PowerPoint.
ANOVA, okay. Big screen?
Yes.
Okay. All right, guys. So this is going to go kind of fast. Not fast, it'll just go, it's only like 19 slides, so we'll get done fairly quickly. And you should have notes there, and again, they will be explaining, you know, the major concepts. And again, this is being recorded, so yeah, if you're looking at this later, make sure you have the right set of notes. It should be labeled something like Basics of ANOVA at the top, and if you don't have them, just pause the video, okay? And come back and get them. Now, for ANOVA, by the time they'll be short, we're going to talk about how ANOVA is similar to a t-test, okay? So it is as far as what it's used for, okay? And again, guys, we're talking about really basics here. There are two basic types of ANOVA that you need to be familiar with, and you need to know when each one is performed, okay? That's where the meat of the questions are going to be, like as far as exam 2 is as far as stats stuff. The math, Excel will do that for you, okay? So don't sweat that, but knowing what types of ANOVA or what types of t-test are used is more important. You're going to know the proper conclusions. This might be the most important thing in the whole deal for both ANOVA and t-test, is knowing what you're supposed to conclude. Okay, and it's all going to be about this p-value here. And there's conclusions if it's greater, there's conclusions if it's less. You're going to know when you do follow-up tests, and you're going to know what the correct tests to perform are, and that's it. Okay, guys, so if you're sitting here having no idea, that's why we're doing this, is so that you can learn. All right, so please don't be confused. But I can guarantee you guys, listen to me. Get with people who can help you, okay? It takes a while. Hunter can vouch, Malav can vouch, I can vouch, okay? Like, it takes a while to get this stuff. So if you think you have it, you probably don't have it. And again, let me say this. Like the practice stuff that you guys are going to be released to today, I will keep turning that around to you until you get it perfect. So you are guaranteed a 100% on that practice. The only way you can screw that up is if you wait until the last minute to turn it in. If you turn it in at 10:28 on Friday night, like okay, so what I'm telling you, Christy or Kennedy or whoever is, go on and get started. Now, don't just put down a bunch of gibberish and make me fix it. That doesn't do anybody any good. I mean, don't do that, okay? But if you turn the practice around to the practice, then I will look at it and I'll say, you got this one, this one, this one, this one, this one right. You got this one wrong. What were you thinking? Fix this. Go back and read. And then you'll resubmit. And then once you get it 100% right, Corey or Kennedy or Elizabeth, whoever, only then will I release the homework to you. Okay, does that make, now the homework, you get one shot. Okay, Christy, so the practice is designed to help you know how to do the homework. Okay, so once you turn in the practice and you're good to go, I will release the homework to you. Then you can turn that, once you turn that in, I release the next practice to you. Does it make sense? So it's just module, module, module. Okay. Now, the only trick is, guys, if you get way out in front, like I'm not planning on covering correlation until next Monday. I mean, I guess I could put up a video for you if you want to look. That's fine. I don't have a problem with it. But that's how it's going to work. Okay. Now, there will be some of you guys that will get done with 2/3 of this by the end of the week. I ain't got a problem with that. There'll be some of y'all that will wait until April 23rd. I have no idea why. It's nice outside. Don't do that. Okay. All right. Okay. So what's the point of the ANOVA? You're right there in the middle of page 1. The ANOVA is just like a t-test, okay? But How many groups do we compare with a t-test? Michael, you out there?
Two.
Two, right. And what are we comparing, Michael? We're comparing the group what?
Average.
Average or means, measure central tendency. You take group one, average, group two, average, and you T them together, and that's how you compare it. Two groups equals t-test. If you're only comparing two groups, it's a t-test. If you're doing a t-test, it's only comparing two groups, okay? Now that doesn't tell you what type of t-test, but if it's two groups, it's t-test, okay? And ANOVA just compares more than two group means, okay? So you're right there in the middle of page one. How many group means? Minimum, it's a minimum of 3, right? It could be 4, it could be 12, it could be 150, okay? But if you're comparing more than 2, that's an ANOVA. All righty, so keep that in mind. There will be questions where I'll say, you know, Christy was testing leg strength before, during, and after an exercise training program, 12 weeks. What kind of test are you going to run? Right off the bat, you need to say ANOVA. That's half the points, right? If you say t-test, you've screwed it all up. Okay, and there'll be some of you guys that'll do that. Okay, so please review with each other, police each other. I promise you, if you do that, you'll be better off. Okay, now remember from the t-test, remember, Michael, we had a curve and we had another curve, okay? And then right in here, Michael, remember there would be like a value right here, remember?
Yeah.
What is this, Michael?
The mean.
Group mean A, group mean B, and so on, right? And we had this difference right here, right? And we wanted to know, are they different enough where we can say they're different, not just because of random, but maybe because of something real. So if you added a third group to this, there, now you've got an ANOVA. So now how many group means do you have, Michael?
3.
3. 1, 2, 3. So then, guys, now listen, it starts getting all wacky crazy because let's say this is 1 and this is 2 and this is 3. So how many comparisons you going to do? You got to go bear 1 to 2 and 1 to 3 and 2 to 3, right? You see how that works? And so it starts becoming like an elephant. You know, you're trying to eat an elephant. You got to do it one bite at a time, okay? So again, 3 or more groups, it's ANOVA, okay? And again, we're asking ourselves the same question there in that little box I gave you. We're just asking, are they far enough apart that we can conclude that the difference is because of some real reason and not just because of randomness or error? Okay, keep repeating that. Keep repeating that. Michael, I'm going to keep coming back to you. More than likely, almost always, if you compare two groups, are those values going to be different? Almost always they are going to be different, right?
Yeah.
We just want to know if they're different only because of a coin flip or because of something real. Like if Michael comes in and always sits in this chair right over here every day, and Christy moves around and everybody else moves around, is Michael sitting over there because the air conditioner's blowing on him or not or whatever? We don't know, okay? But we want to know whether his behavior is different compared to everybody else's, okay? And then we can investigate, then we can ask why. Yeah, so we will use the ANOVA. So yeah, and it's the same thing as we talked about t-test, with less overlap of those curves, if they don't overlap as much, there's less probability that the difference is because of random chance. So we will use the ANOVA. You're right there in that bottom with that arrow to determine if the difference among all the groups is statistically significant, far enough apart to be statistically significant. Okay, y'all got it? I'm trying to go slow. Michael, you okay?
Yeah.
All right. And guys, if you're lost, if you're 100% lost, you have 3 choices here. You can either just say, I'm lost, no problem. You have 4 choices. You can say, I'm lost, no problem. You can speak up now. You can email me later, or you can contact one of your friends later. Please don't be lost and get to the end of April and be just as lost. Okay, you can come by my office. I'm happy to help you with this stuff. This stuff is actually fun if you can get the light bulb to come on. Okay, so if you're lost, please don't be embarrassed. Please come ask me at some point in time. Okay. Okay, so yeah, when we do the ANOVA, that's going to allow us to do one of 2 things. We're either going to reject that no sig diff hypothesis. So if we reject the idea that there's no significant difference, then we can actually say that we're going to default that there is a significant difference. Okay. Remember, if we reject the hypothesis that there's no significant difference, then we are therefore accepting the fact that there is a significant difference. Or if we fail to reject the no significant difference hypothesis, then we are in fact going to conclude that there is not a significant difference. All right. So that's the front of page 1. That bottom very part there, right below where it says, remember, if we reject and if we, you guys need to bracket that, study, understand it, get it. Hunter, you out there?
Yes, sir.
Am I right in saying that the null hypothesis, you have to wrap your mind around it 15 times and rehearse it and get it, rehearse it and get it, right?
Yep.
Yep. He knows. He knows. If y'all hang around for a while, I'll give you Hunter's number. Okay, that's fine. You can call him.
Maybe not, that'd be a good thing.
He's going to go incognito, right? It's a wise man. Okay. All right, flipping to page 2, okay? But seriously, guys, the bottom of that page 1, where we're talking about the no sig diff hypothesis, you got to get that. It does kind of play with your mind, so you just have to get it. And guys, seriously, I mean, Hunter, you may think of a better way to explain it, or whatever, Elizabeth, whatever. If you guys come up with a different way to explain it, tell each other, help each other out, because some people just get it, and some people, they need analogies or something like that. So please help each other out. I mean, this is one of the few things where I'm encouraging you, please cheat. I mean, don't cheat, but please help each other. I mean, what do I think y'all do? Like, y'all don't just go home and not help each other. Y'all have text numbers and everything, right? Corey was texting people last week, telling them how internships work, right, Corey?
Yes, sir.
Yeah, right. Yeah. He was on the phone with me when he was doing it. Okay. Has anybody registered for internship today? No? Okay. You may not be able to yet. Okay. Page 2. There are 2 types of ANOVA. There's the one-way and the repeated measures. Okay. So that's all we're going to do is one-way and repeated measures. Okay. So you're at the top of page 2 here. The one-way ANOVA, it is similar to the independent samples t-test. Okay. So in this case, you are comparing data from at least, and you want to write 3 different groups, 3 distinct groups, something like that. Okay. 3 distinct groups. Yeah, and there's a question on there about what are some examples of groups you'd use a one-way ANOVA. So here's a good example, guys. Good example. Pre, during, or post. Actually, you know what, guys? It's going to confuse you. Don't write any more of that. Don't write any more of that. Don't do that. Chrissy, erase that. Erase that, guys. Let's do this. Here's a better example. Young, old, and elderly, or something like that. You know, you can say young, middle-aged, and old, or whatever. Okay. So 3 different groups of people, 3 distinct groups of people. That's an example. Another one would be like exercising a certain day a week, exercising another day a week, exercising different. So here you go. Here's examples. Do differing doses of 30 minutes of aerobic exercise per week end up with different blood pressure results? So what's the independent variable here? What are you choosing to change? What are you directly changing? It's your dosage per week. That's what you're doing. You're putting Christy in one group and Michael in another group and Corey in a third. Okay? That's your independent variable. And you're right there in the middle of page 3 or page 2. So look. So for example, here's 3 groups. Here's group 1. Group 1 is 0 to 2 days per week. There's your group 1. You see where you are, Christy? Yep. Here's your group 2. Here's your group 3. Okay. Elizabeth, you okay? Hopefully. Are you lost? You okay? Don't let me lose you all. You okay? All right. Okay. Matthew Lewis, you okay? Good, thank you. Very nice, very nice. Got the thumbs up. So if you're lost, chat each other, ask me, that's fine. Okay, but this is your 3 groups, 1, 2, 3. What's the dependent variable? Anybody, I'll take anybody. Come on, guys. Take a risk.
Blood pressure.
Blood pressure, right, guys. Yeah, so that's your dependent. Blood pressure is your dependent. I'm going to ask you that again, guys, on the second exam. You got to be able to get it. Simple, simple. Y'all good? Christy, you okay? Thank you, Corey. Very good. And if y'all need me to slow down or whatever, just raise your hand or whatever. I mean, I think we're all kind of figuring out finally how Zoom emojis work or whatever, okay? Yeah, so look, here's the difference. A t-test might compare active and sedentary. So that's your 2 curves. So if you guys want to label that, this is an example of a t-test. Here's your active. And here's your sedentary. How many groups? There's 2 groups. What kind of test? A t-test. So if you want to label that on your pages there, it'll help. But an ANOVA, well, say I did it. See, I'm brilliant. There you go. An ANOVA is going to compare these 3 groups. Now watch. Here you go. Here's 0 to 2. Here's 3 to 4. And here's 5 plus. And here, what is this, Michael? What's this number right here?
The mean.
Group what? Group mean, right. By the way, guys, here's your independent. 3 settings of an independent. What's this dependent variable going to be? That's going to be probably millimeters of mercury, right? Because that's blood pressure. See? Okay. So that's a one-way ANOVA. 3 different groups, at least 3 different groups, one-way ANOVA. Now, a repeated measures is going to be similar to a paired t-test. So for example, it's three, yeah, so on your paper it's got, it's three groups, or it's one group, I'm sorry, assessed at least 3 times. One group of people assessed at least 3 times. One group right there at the bottom. Christy, you got it? It's one group assessed over and over and over again. You repeat it. Measure, measure, measure. Okay. So your time point is going to be your independent variable. That's when you're looking at it, and when you're looking at it again, and when you're looking at it a third time. Okay. There's your dependent. It's body fat percentage. Michael, if we were going to just look at pre and post test, pre and post training, what kind of, if we just pre and post, what kind of statistical analysis will we use in general?
Sorry, I didn't hear you.
That's all right. If we were going to look at just pre and post training, if we were going to look at them before training and after training, what kind of general statistical test will we use?
It would be a t-test.
It'd be a
because it's
t-test.
two
It's just
groups.
2 times, right? Right? Okay. It's a paired t-test. All right. So here we go. Yeah, at the very bottom of page 2 there's your 3 time points: before starting, halfway through, and finishing. That's your independent variable, and your body fat percentage is your dependent. Christy, you good? All right. Hunter, back me up on this. I could make this a lot more complicated, couldn't I? This is about as simple and as straight down the line as it needs to be, right?
Yes.
He doesn't even have to think. He's just like, yep, that's right. I think he knows. He doesn't want me to make this. You've probably seen more complicated, haven't you, Hunter? I imagine. Or maybe you haven't, have you?
I haven't done ANOVA, but we did the t-test for biology.
Okay. Was it more complicated or pretty good?
We had to do like all the studies ourselves, so it's complicated.
Ugh, okay. All right. Okay, so here you go. So guys, again, this is just a graphical representation here, and you're just kind of cruising here. So here's your t-test. So Michael, here would be your pre and post. Here's your pre. There you go. There's your post. So it's a t-test. But your ANOVA, okay, your ANOVA is going to compare that pre, midway, and post. All right, here's your dependent variables right here. DV, that's body fat percentage. So you look at difference here, and difference here. Right? All right.
I have a
Flipping
question real quick.
Yep.
So this may be like completely separate, but in one of my classes, we recently did like the Australian rhyming, like the cycle test.
Yep.
Would that be kind of something that an ANOVA would compare, because you keep up with heart rates like all throughout the test?
You do like different points, don't you?
Yeah, so like you do it like resting and then like for different stages and then at the end as well.
Yeah, I mean, theoretically, yes, I think so. The trick is that like you're an individual, you're not a group. Does that make sense?
Okay.
Yeah,
Yeah.
right. So that's like keep coming back to that the purpose of these statistical tests is to really compare groups.
Okay.
Okay. Does that make sense?
Yeah, so like you could possibly do like if you did multiple classes using
Yeah, I
that
mean,
data.
an A strand is probably, and again, this is going to get way off in deep field, left field, but an A strand is probably based more along the lines of what's called a regression, where like you have this final value and you're using it to kind of like make a line of best fit as far as what their
Yeah.
what their fitness. Yeah, that's more of a regression.
Gotcha.
Where,
I
and
was just
that
trying
again,
to,
don't
yeah.
go looking that up. You'll want to throw yourself in front of a truck if you do that. It's awful.
Okay.
But
Thank
the key thing is like with what we're doing here today and t-test and correlation, it's really about comparing groups. Just remember that. And specifically group averages. Okay. Really, no matter what, you're going to have groups. Okay. Because otherwise you'd be, I mean, think about it. You'd have to, like for you to get a good idea of the average body fat percentage of a student at MTSU. Well, think about it. Was it like 30,000 students by the time you add them all up? Like you're not going to go out and ask everybody what their body fat percentage is. So what you want to do is ask enough people where you can have an idea of like, you know what, this, and it has to be representative. You can't take them all from exercise science or all from, I mean, I don't know, some place that sits a lot, like, somebody that doesn't ever move, because then it would mess it all up. Does that make sense? You understand what I'm getting at?
It does, yeah.
So, I mean, and again, that's kind of higher level, but it's really all about comparing group averages. Okay. That's
Gotcha.
really what it comes down to. Okay. Every ANOVA has this, you're page 3. Don't lose this page. Don't lose any of them, but this helps break it down. The first step in ANOVA this is the first step, is you're testing to see if there's a difference somewhere. Now, I want you to think, Anna, were you the one who was asking? Yeah, I think your screen turned on. Were you asking, Anna?
Yes, I was. That
Okay.
was my question.
Yeah, so guys, think about it. And again, I wrote this down for you guys. You guys are fine. But when you think of like 3 groups, it's really not that hard a concept. It's kind of, yeah, okay. I mean, I got it. But think about it, Anna. If you started think about it this way. If you had 7 groups, I mean, I'm not going to draw them all out, okay? But you get the point. Think about it, Anna. If you had 7 different groups, well, I will draw them all out. 1, 2, 3, 4, 5, 6. I mean, start thinking about this, Anna. You'd have to think about how many t-tests you'd have to run here. You have to run one here to here, 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 here to here. You see what I mean? See, we could be doing this all day long.
Yeah.
And think about it, Anna. Think about it. If you start running all those t-tests, you have to start bringing your alpha down so far, because you could have error introduced into any one of those t-tests and it starts extrapolating on itself, okay? So that's why we do an ANOVA, is because it tells us whether there's a difference somewhere among the means. That's the first step to ANOVA. And you can't tell where it is yet, but you can figure out whether it exists. And guys, you interpret this the same way as a t-test. You compare that p-value to, really, it's to whatever your set alpha is, but generally it's going to be 0.05. Remember, the p-value is just a probability that the difference you see is because of randomness or error. Anna, the p-value doesn't mean anything unless you compare it to what your accepted risk of that is. That's the alpha. Okay? So just remember that. And that's going back to hypothesis testing, I think. Get that down. That p-value all it is a measure of probability. It's p, probability that the difference you see is because of randomness or error. So if you're saying 0.05, that's a 5% chance. You're saying I'm willing to accept a 5% chance that the difference is because of randomness or error, because there's a 95% chance that it's not. Okay. If you've been in my office enough or you've talked to me, I've probably said before, I've got a 95% chance. I'd be willing to, I'm saying I'm 95% sure that blah, blah, blah. You know, that means I'm pretty confident. Okay. Okay. So it's the same way as a t-test, guys. If the ANOVA p-value is less than the alpha of 0.05, your interpretation of the t-test see, I messed up. Your interpretation of the ANOVA is that there is a difference, a significant difference among the means. We'll take out that probably. All right, so that's that question right there. You guys, it's like the third line down. If the ANOVA p-value is less than the alpha, your interpretation is that there is a difference among the means. Okay. If your ANOVA p-value is greater than 0.05, you can't confidently say that a difference exists, because what might be causing the difference, Michael? It might not be a real difference for something real. It might be because of what?
Random error.
Randomness or error. Okay. Right. Yeah. Remember, there you go. See, I'm smart. Remember that a difference greater than 0.05 could be attributed to randomness or error. I know, you know, guys, every time I teach this, I end up feeling exhausted by the time I get done. It's just because I'm really trying to just go so slow, because it makes me tired doing this. So if you haven't had stats before, please don't overestimate yourself and don't underestimate how much you need to get this, okay? While I'm thinking of it, if you have not told me yet whether your computer has the Excel data analysis package on it, I need to know that, okay? Well, most of y'all have replied, but there's still a few of you that I haven't heard from, so please tell me. You can chat me or email me or whatever, but okay. Now, you're in the middle bottom of page, middle half of page 3. If that p-value is significant, you then need to find out where the difference is, okay? So you're going to run follow-up t-tests if a significant difference exists. You're going to run follow-up t-tests if that p-value is less than your alpha. If that p-value is less than your alpha, a significant difference exists, and you're going to have to run t-tests, because then at that point, I keep saying Anna only because, you know, see, when people speak up, then all of a sudden I just latch on to them. I'm so sorry, but so think about it. I mean, like, yeah, if you got 3 here, okay, and we find a difference among these means, now we're going to do follow-ups. We're going to do here to here, 1 to 3, or 1 to 2, 1 to 3, and 2 to 3. Because we got to compare those pairs now. Yeah, you systematically can compare each pairing. Okay, yeah.
So depending on the number of tests you have will kind of determine of how in-depth the step 2 is.
It really doesn't depend on how many tests you have as much as whether that p-value is significant or not.
Yeah.
That's all it is. Yeah.
Yeah.
It gets beyond the level of this class, but if you start getting a whole bunch of different groups, then your alpha has to come way down. I'm not going to go past 3 in this class. I mean, it would be suicide, but I mean, it's hard for me to understand. So, you know, whenever you start comparing lots of different groups of people or lots of different groups of data, there's a chance that error could enter into any of those measures. And then if you get a huge amount of groups, it's just like, well, by chance, you could screw the whole thing up because you got error upon error upon error upon error upon error. So you have to take that alpha down, 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 down to kind of push that out, and it ends up being awful. Okay. The type of t-test you use depends on what kind of ANOVA you performed. Okay, guys? So you're right there at the bottom of page 3. If your original ANOVA was a one-way, you're going to be testing different individual groups. So you're going to do an independent samples for a follow-up. Independent samples t-test for follow-up. If your original, there you go. Yep, here you go, Anna. Here's your groups: blue, red, green. Oh, I remember I took forever to make this slide. I'm proud of this slide. Watch out. Yeah, blue, red, green. Here we go. Watch. Blue, red, green. So you found a difference. You compare group 1 to group 2, group 2 to group 3. Man, this is awesome. Look out. Watch it fade. Watch. Group 2 to group 3. Watch this. Man, see, look. See, y'all have any idea how long it took me to make this? Like, while y'all were on spring break last year when COVID was breaking apart, I was doing this. Good job, Mr. Clark. Way to go, Mr. Clark. Thank you. That's good. Okay. Does that make sense though? Really good. And don't forget, this is being recorded, so you need to go back and look at this. It's fine. But here's your pairwise comparisons: group 1 to group 2, group 2 to group 3, group 1 to group 3. There you go. Anna, does that make sense?
Yes, it does.
Perfect.
That was helpful, by the way. Nice job on the slide.
It took me like 20 minutes to do that slide. You just go back and like watch this all night. Let's do this all over and over again. Like that. Like the animation chain on this is like that long. Okay. The follow-up for repeated measures. If your original ANOVA was repeated measures, you have different time points that are compared to each other. Okay, so then you're going to do a paired samples for a follow-up. You're still doing a follow-up. Okay, you know, if this is significant, if this is P less than 0.05. So yeah, here's your beginning, your middle, and your end. So watch this. Beginning to middle, middle to end, beginning to end. Okay, that's all the complexity. And again, you're not going to know how to run ANOVA yet because I haven't told you, and I don't even know if I'm making y'all run ANOVA. I may just be making you look at the outputs. Okay, I think that's what I'm doing. You guys have to mentally and emotionally commit to me that when you start doing this practice and the homework, well, practice specifically, you've got to come to Zoom office hours or something and come and talk to me. Okay, trust me. Christina can vouch. Like, Christina got on Zoom with me. Are you still there, Christina, or did you leave? Is she there?
I'm here.
Yeah, she got on with me last week, and in about 5 minutes we had it figured out, didn't we, Christina?
Yeah,
I smacked you around a little bit, didn't I?
just a little bit.
Okay, though, it made sense, right?
It was actually really helpful. So thank
See, I mean, like, I knew that's how I led her into my trap. I told her that. You know, she's like, "Well, that's what you said." Oh, I said, "Yeah." It's okay, Christina. Other people do the same thing. It's fine. Okay. All right. Okay. Everybody, take a deep breath for about 1 minute. I'm gonna pause the video here. I'm gonna get my breath, and everybody just pause, and we'll look at this. We'll look at examples really quickly. Okay. So everybody just pause. So now we'll look at the ANOVA output, and this is on page 4, and this will be it. So this is an example of ANOVA output from Excel, and I went on and printed this out so you guys would see what. Don't lose this page, okay? So we're looking at repeated measures ANOVA comparing squats to fatigue over 3 days. So it's the same group tested on one day, and then the same group tested another day, and the same group tested on a third. Same group of kids. Squat to fatigue on Monday, squat to fatigue on Tuesday, squat to fatigue on Wednesday. What would you think? How many squats do you think they would be able to, what do you think? You think they'd be squatting less by the third day? If they did them day after day after day to fatigue? I'd be willing to bet you they do less on the third day, don't you think? Because they're not recovering, right? So it's a repeated measure. So look, all you guys have to worry about, and if you want to use a pencil, okay, all you have to worry about is this p-value right here. Okay, for my purposes, that's all I want you to worry about is that p-value. What does that tell us? I've got a question there. Our follow-up, Anna, you can be the hero or the goat here. Sorry. Our follow-up test needed for this ANOVA? You have a 50-50 chance being right, Anna.
No, you do not need. I was
No, they
wrong.
are needed. See, it's okay. It's okay.
Okay, I got it mixed up.
No, it's okay.
No,
and
it's
that's fine.
0.05.
Right. And that's fine. See, this is, and she walked right into it, which is fine. Like, guys, like, trust me, like, I have to think through this, okay? Hunter, he can back me up. He can tell me, like, every time you think you got it, you always have to sort of reset. Like, right, Hunter? I mean, unless you just do stats for a living. I mean, that's just the deal. Okay, so right, Hunter? I saw him unmute.
Yeah.
Yeah, he knows. So yeah, that p-value tells you that there's a significant difference somewhere among those three means, Anna. Now you have to figure out where using t-tests, okay? And by the way, what kind of t-test were we going to run? This is repeated measures. So the type we're going to run would be paired t-tests, I think. Yeah. Okay. Okay. So you compare day 1 to day 2. No significant difference there. Day 1 to day 3, yes, a significant difference, and day 2 to day 3. So listen, did they get more fatigue? Was there difference in the squats to fatigue from Monday to Tuesday, Michael?
I think.
No,
What
no,
I'm
because
looking at.
right here. Here's your,
Oh,
like
my
if
bad,
this is
my bad.
Monday and this is Tuesday, here's Monday, here's Wednesday, and here's Tuesday, and here's Wednesday. So between Monday and Tuesday, did they squat significantly less to fatigue? No. Look, see Anna, see that? But between Monday and Wednesday, they squatted significantly less, and between Tuesday and Wednesday, they squatted significantly less. Okay, so they got more fatigued later on in the week, sort of. Does that make sense, Anna?
Yes. So in a way, we're looking for basically the more difference is considered.
Yep.
Good. Okay.
Yep.
Gotcha.
Yep. Think of it this way. Listen, guys, listen. If the average for squats to fatigue on day 1 was 25, and on day 2 it was 23, and on day 3 it was 19. Even though this number is less, it's not significantly less. So you can't compare those averages, Anna, because it could just be because of randomness.
Right. That makes
Does that make
sense.
sense?
Mhm.
But you can definitely say that they got fatigued from the beginning to the end. They got fatigued from the beginning to the end. They actually squatted on average 6 less to fatigue at the end. At that point, if there's a difference, if there's a significant difference, you can legit compare the means. If there's not a significant difference, you can't compare the means because it doesn't mean anything. They could be random. Does that make sense? Y'all got it? Good? Okay, thanks.
Yep.
Good. And we'll go over that and you guys will screw it up. That's why I'm doing practice, is so that you can get it down. Okay. Whoop. Come on, baby. There we go. Yeah, there you go. And again, guys, this is being recorded. All right. So please go back and look at this. That's the beauty of this. Yeah, these are paired samples t-tests. We looked at everyone over and over again, paired samples. Man, this is wearing me out. I know it's wearing me out. This is like the most tiring lesson of the whole semester. I'm so sorry, guys, but like, all right. All right, Anna, it's redemption time. She wants me to quit picking on her. Like, okay. So this, well, crap, I messed up. Congratulations, Anna. So, okay. All right. So you're comparing blood pressure. So we don't look at any of this. I think did you see what it came up there, Anna? Or?
Yes, I'm looking.
Get your answer formulated. You got about 1 second. All right. So they had 3 different groups. We have 3 different groups. Were they, one that did nothing and one that exercised, whatever. All right. So did they have a significant difference in their blood pressure among those 3 groups?
Yes.
No, Anna. It's okay. No significant difference.
Okay, I suck. I'm so
No,
sorry.
it's okay. It's okay. Anna, it's fine. You're being a good sport, okay? But trust me. Again, I keep asking Hunter because he'll back me up, but trust me, like, you just have to practice it, and you almost have to not overthink it. You almost have to knee jerk it. I think Hunter would agree. Like you don't, like, once you get down the P less than or greater than, then it's good to go. So Anna, please come see me, okay? Seriously.
Okay.
Like,
Yeah, I
please
think
come see me
I'm on the right track. I just have it confused that no significant difference means no further
Right. Yep.
testing.
Yep. I
Whereas
know. I
yes,
got it. I got it.
yeah, okay. So
and
I'm on the right track, but
yeah.
yeah.
And Hunter would agree with me. Like, there's this whole thing about the null hypothesis, and I just found that just messes people up. Good job, Christina, by the way. It just messes people because then you're thinking null and none, and it's like a double negative, and they're just all freaking out, So I just find that it works better that way. Yeah. So, and again, it's being recorded, so please, just screenshot. I don't care if the p-value is greater than your alpha, ding ding ding, then you don't need to do any follow-up tests because you already know there's no significant difference among all those means. No need to go any further. So what kind of t-test would have been run? That would have been an independent samples. Okay. These are 3 different groups: the non-exercising, the exercising a little bit, and the exercise a lot, or whatever. Okay. Okay, let that percolate and digest. Okay, this might be the hardest lesson of the whole thing right here. Anna is such a good sport. So Anna and everybody else, I encourage you, go back and review over hypothesis testing and the p-value, and go back and do the t-test and kind of get that down, and then pass back to this, and you'll be good. Commit to that, okay? Because if you haven't really done it, which I don't know who hasn't, but it's going to be Greek to you, almost literally. Okay. So go back, practice. And even like on the notes for the hypothesis testing, I think there's a little chart there about p-values at the end, like, decide, reject, or accept, or whatever. Go back and look at it. They're recorded. They're there to use. Go back and look at it. Okay. All right. Any questions? Okay, guys, so I'm going to stop recording. I know that was a lot, but we just had to go slow on that.